Let's record this part. So again, this is the power rule. If you have any term of this form, where you have a coefficient a, for example, times x to the power of a number, and you want to derive it, to use the power rule to find the derivative of this thing, all you have to do is multiply the whole thing by its power, so na, right, because the power was n, and then subtract 1 from the power, and that's it. You've derived your function, or you've derived your term. For example, you get 4x cubed, just multiply the whole thing with 3, because that's the power, right? So 3 times 4x, and then subtract 1 from the power, so 3 minus 1 becomes 2. So that means 12x squared is the derivative of 4x cubed. And that's it. So, in this question, you're given a function and you want to find its derivative first. To find its derivative, all you got to do is multiply 5. So first take this term, right? So multiply the whole thing by 2, which is the current power. And then subtract 1 from the power. So 2 minus 1 would become just 1. And what about the constant terms? So there are a bunch of ways to think about what the derivative of a constant term is. The first way is to simply use the power rule. So do you agree with me that 3 can be written down as 3 times x to the power of 0? Do you agree that these are equivalent things? Because x to the power of 0 is just 1, isn't it?
Mm-hmm.
So this is the same as this. So deriving 3 is essentially the same as deriving this. And how do you derive this? Multiply the whole thing with the power and subtract 1 from the power. Doesn't even matter what you did because you're multiplying by 0, which means that every constant will get derived to make 0. Constants die out when you derive them, basically, is what the moral of the story is. Okay?
Yeah.
So if you want to remember something, just remember that if you see a constant term, you simply derive it to nothing. It just goes away. Okay? So your derivative turns out to be 10x. Now what does this mean? What does it mean when I say the derivative of my function is 10x? Look, how does a function work? A function works like this. You have, what's your function? 5x squared plus 3, right? You give it an x value. And what does it give you? If you plug in an x value into a function, what does it give you? It gives you the y value at that x value on the graph of that function. Right? So what you've just found out is that when x is 1, y is 8. Right?
Mm-hmm.
So a function's job is to take an x value and give you the corresponding y value. That's what a function's job is. So what is a derivative's job? A derivative's job is to take an x value and give you the slope at that x value. So for example, if in the derivative of this function I plug in x equals 1, I will get, so if I plug in x equals 1, I will get 10 times 1, which is 10, which means that when x is 1, the slope of the graph is 10. And this means that when x is 1, the y value of the graph is 8. So the function tells you the y values, the derivative tells you the slopes. Okay? That's the main idea of what our derivative is. Is this clear?
Yeah.
All right. So you found the derivative using the power rule. By the way, part A was done here. The rest of it was just me explaining what it means. Okay. So I'm going to put that explanation on the side for now because we need this space. It's very, very precious space, even though this whiteboard is infinitely big. Anyways, so part B now. So part B is exactly what I just explained. See, oh, okay. They even use the same number, coincidentally. It says, find the gradient of the curve of y equals f of x at x equals 1. Okay? So do you agree that this function will make a curve? You know, some kind of curve. It's going to be a quadratic, it's going to be a parabola, by the way. But doesn't even matter. So that's what they're saying. This is the function. You found that function's derivative. Now find the gradient of that function at x equals 1. What do they mean? Whenever someone asks you to find a gradient of a curve at an x value, all you gotta do is plug that x value into the derivative. So again, put this on a sticky note and take this with you and read it just before the exam. This is the cream of everything, basically. This is basically the main idea of derivation. Finding the gradient of a function at any x value. Take the derivative, plug in that x value into the derivative, and that's your job done. The answer is 10. That's it. Is this clear?
Mm-hmm.
So we can call this the gradient, slope, or even derivative, because all of those things mean the same thing, of y equals f of x at x equals 1. Because that's the job of the derivative, telling you the gradient or the slope or the derivative, synonymous words, at any x value. Okay. Similarly, the next question says, what is the coordinate of the point where the gradient is 20? So when they say gradient is 20, see, earlier they said find the gradient. That was me understanding they want me to find the derivative, because derivative and gradient are synonymous words, right? Similarly, now they're saying the gradient is 20, which means the derivative is 20. You see what I mean? So all I gotta do is understand that what they're saying is the derivative is equal to 20, solve for x. So what's the derivative? 10x. What's it equal to? 20. Find out what x must be. X must be 2. Because if I divide both sides by 10, I will get x equals 2. That's the answer. So remember, gradient and derivative are synonymous. They're the same thing. Does this question make complete sense now? All
Yeah,
parts.
I think I need to practice it some more, but I
I'm gonna
understand
give
it
you guys
better than.
a similar question now to try out. By the way, you guys remember the law of exponents, right? So for example, when I show you a function that looks like this, you should know that the function, instead of writing square root of x, I can write it down as a power of x. What would that power be? How do I write square root as a power of x? So it's not 2, right? Because 2 would mean square. So how do I write square root?
I was gonna say two, but
No, 2 means square. 2 means like just regular square. Square root. So roots are written as denominators. So 1 over 2, this division by 2 in the power implies a square root. If it was 3, it would mean cube root and so on. Okay? So again, if you have roots, they are written as 1 over that number. And if you have regular powers, they are written as the top number. So the top number is the normal power, and the bottom number is the root part. Does this make sense now?
Mhm.
Okay, make sure you revise indices slash exponents, same thing. Just, I don't know which word I used when I taught it to you. Okay, this is from there. Anyways, the reason you need to do this is because otherwise you cannot use the power rule if you don't know the power of x. So you need to convert these weird symbols and stuff into power so that you can derive it later on. Okay? So what I want you guys to do now is try to do this question using exactly what I did in the previous one. Okay? I'll give you 5 minutes for this. Do not take longer. And that's let's circle back then. Okay? So let's just quickly go over the solution one more time. Okay, so we have a function. First of all, we convert that function into the power form, the index form, because you cannot use the power rule to derive something unless you have the powers of all the variables. So root of x becomes x to the power of 1 over 2. This is from indices, so if you do not know this, revise those. Now, to find the derivative, all you have to do is multiply the whole thing by the power, so 1 over 2 times 4x, and then subtract 1 from the power, which gives you this. Now remember, you're always subtracting 1 from the power. Okay, multiply by the power and then subtract 1 always. So you get this as your derivative. Now, that's the first part done. Second part says find the gradient when x is 1. That's basically it. That essentially just means plug x equals 1 into the derivative, because whenever you're told to find the gradient, you need to find the value of the derivative, because value of the derivative is the gradient. So you plug in x equals 1 into the derivative, solve, 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 and you get this answer. That's it. Last part says find the point where the gradient is 1. Okay? The gradient is 1 means the derivative is 1. Okay? So what we do is we take the derivative, set it equal to 1. And then we just do a bunch of algebra to solve for x. How? First of all, You can rewrite x to the power of minus 1 over 2 as 1 over x to the power of, 1 over root of x. Since there's a 2 here, there's a 2 at the top. So 2 over root of x. Then you can multiply both sides by root of x, which gives you 2 equals root x. And then to remove the root, square both sides, which removes the square root from the square root of x. By the way, I missed it earlier, but it says find the coordinates, not just the x value. So once you know the x value of the point, you can plug that x value back into the main function. Why? Because we want the y value. Okay? A common mistake I see people doing is to find the y value, they plug the x value into the derivative. Why is that wrong? Why can I not plug in the x value into the derivative to get the y value? Anybody? Why can I not plug in the x
Is
value
it,
in? Sorry?
is it because I is fx
Exactly. Y is not coming out from the derivative.
equals?
Y is coming from the function itself. The derivative only gives us slopes. If I want the y value, I gotta plug this x value into the function, the main function. So the main function is equal to 4 root x, which means if I plug in 4 to get the y value at x equals 4, I would get 4 times root of 4, which would give me 4 times 2, which would give me 8. In fact, there's an interesting point here. Root of 4 can give me plus or minus 2, which means I have two answers, plus or minus 8. So there's 2 points actually that have a slope of 1. What are those 2 points? X equals 4, y equals 8, and x equals 4, y equals negative 8. Both of those work. See? X equals 4 obviously in both of them, but y can be two different things, plus or minus 8. So these are your answers. And that's it. So this is the most basic kind of question you can expect in an exam. But honestly, it's better to just not expect it. It's so easy that I don't think it should show up in an exam. The questions that actually show up in an exam are more about tangents and normals. Let's talk about tangents first. Look, whenever you have a curve, okay, so let's say f of x equals x squared plus 5, okay, this curve looks like this. You can make something called a tangent to this curve. What is a tangent to this curve? For instance, let's say I want to make a tangent to this curve at x equals 2. That means I draw a line that has the exact same slope as this curve at that specific point. Okay? Because clearly this curve has different slopes everywhere, right? If you put a person standing over here versus if they stand over here, they're going to feel different slopes, right? The slope is constantly changing. But at a specific point, you can find the slope of the curve by drawing a tangent. Because the slope of this straight line will be the same as the slope at this curve at this exact single point. Does the idea of tangents now make sense to everybody?
Hmm.
Okay. So what have we deduced? We've deduced that the slope of a tangent and the slope of a curve is the same at the point where the tangent was made. Okay, because you draw a tangent at a specific point, of course. So the slope of both of these, the curve and the tangent, will be the same wherever the tangent is drawn. Okay? So in this case, the slope of this tangent, let's call it L1 because it is at the end of the day a straight line. The slope of this L1 line will be the exact same as the slope of the blue curve at x equals 2. Okay? So that's basically the main idea. Now, let's say the question says, find the equation of the tangent of this curve at x equals 2. Okay? Now, a lot of most students get super confused with these questions because there's so many words. Okay? All you have to do is, whenever you want to find the tangent of a curve at a certain x value, the first thing you need to realize is that the derivative of the function at x equals 2 is the same as the slope of the tangent. Okay? This is the main point. And where does this come from? It comes from what I just said. I said that the slope of the tangent is the same as the slope of the curve at the point where the tangent is drawn. The tangent is drawn at x equals 2. So the slope of the curve, that's the slope of the curve, at the point where the tangent is drawn is the same as the slope of the tangent itself. That's exactly the sentence I just wrote down as an equation. Okay? So this is the first very big realization. Now, how do we, calculate the slope of the tangent? We can calculate just, exactly what I wrote down. You can calculate the slope of the tangent by finding the derivative of the curve at x equals 2. We can find the derivative of the curve very easily by just, using power rule. X squared will become 2x. 5 is a constant, so it goes away. As I said earlier, constant terms become they vanish when you derive. Okay? So this is your derivative. General. Now, the slope of tangent will be the derivative's value at x equals 2, which is basically going to be 2 times 2, because I just plugged in 2 into x equals 2 into this derivative, which gives me 4, which means that the slope of tangent is 4. Okay? So I found the slope of the tangent by simply finding the slope of the function at x equals 2, and that's it. Next step, well, what are we looking for? We're looking for the equation of the tangent line, right? Remember, the tangent is a straight line. It's nothing, complicated. It's literally just a straight line. Once you know the slope of the straight line, you might remember, hopefully from the class we talked about straight lines in, that all you need to find the equation of a straight line is its slope and a single point that the line passes through. The good thing is we found the slope. The bad thing is we don't know the full point. The good thing about that is that we know one part of that point. We know that the tangent passes through this point, where x is 2. And we can find the y value of this point very easily, because we know that this point is on the curve, and we know the equation of the curve. So we can find the y value of this point by simply plugging in x equals 2 into the main curve, which will give me 2 squared plus 5, which is 9. Which means that this point, let's call it point A. Point A, therefore, is x value is 2, y value, as I just found out, is 9. And now I know the slope of the tangent and a point that the tangent passes through, which means I can find out the equation of the line by just doing y minus 9 equals the slope times x minus 2. This is the point slope form that, again, we covered in the straight line equations class. So there you go, you have the equation of the tangent. The main idea is to remember what tool is used for what goal, basically. The derivative of the function tells you the slope of the function. Okay, that's one thing. Derivative is slope. The second thing is the slope of the tangent is the same as the slope of the curve at that point where the tangent was made. It's a long English sentence, but it's a very simple idea. Tangent has the same slope as the curve where you draw the tangent, and that's it. Okay, and that's the end of this question, actually. Okay, I'm gonna give you guys 2 minutes to just absorb this, and let me know if you guys have any questions at all. Okay, before we talk about a question to do with tangents, let's first talk about normals, because those are basically just another kind of question similar to this one. Okay, what are normals? Let's take the same exact function, and we'll even copy the way it looks, because it's the same function, so we have to copy the way it looks. I don't know why I said that. So now, what is a normal? A tangent is a line that has the same slope as the function where the tangent is drawn. So what is a normal? A normal is a line that has a perpendicular slope to the graph of the function where the normal is drawn. So this is what the normal would look like. See, it's perfectly perpendicular to the graph. So if you were to look at a tangent and a normal together, you would see that they're perfectly perpendicular to each other at the point where they're drawn. Now, so if we take the thing we said about the tangents and copy it, we can change this slightly and make it look like it's a normal definition. The slope of a normal and the slope of a curve is not the same is, well, you can say that the slope of the normal is minus 1 over slope of curve at the point where the normal was made. So you guys hopefully remember that there is a rule about perpendicular lines where if you know the slope of one line, you can find the slope of the other perpendicular line by just using this formula, right? This is for perpendicular lines. For example, if one line has a slope of 2, its perpendicular line would have a slope of minus 1 over 2. If one line has a slope of 3 over 5, its perpendicular line would have a slope of minus 5 over 3. Minus and flip, okay? So these are perpendicular lines. This is a perpendicular line, okay? Is everybody familiar with this idea? Because this is also something we talked about when we were talking about straight lines in the earlier classes. So a normal is basically just the perpendicular version of a tangent. You can think about it like that, okay? So everything will actually be very similar. So let's say the question now says, find the equation of the normal at x equals 2. So when we say equation of the normal or equation of the tangent at x equals 1 or 2 or whatever, the first thing you have to do is find the derivative, because obviously everything is, connected to the slope of the function, right? Clearly, the slope of the curve is directly related to the slope of the normal, and it's directly related to the slope of the tangent also. I mean, it's literally equal to the slope of the tangent. It's very related. So if we find the slope of the curve itself at x equals 2 first, then we will be halfway there already. So to find the slope of the function itself, we have to first derive the function. And then to find the actual slope, we have to plug in that x value into the derivative and get 4. Now, this is the slope of the curve. If I wanted to find the slope, the equation of a tangent, I would say that this is also the slope of the tangent. But I'm not looking for a tangent, I'm looking for a normal. So I would now say that the slope of the normal would be minus 1 over that. Right? So earlier, when I found the slope of the curve, I said the slope of the tangent is the same, because it is the same. That's the whole point of a tangent. The slope of the tangent is the same as the slope of the curve. But this time, I found the slope of the curve, and I said the slope of the normal is minus 1 over that. This is the only difference. Everything else is going to be ditto the same. Okay? So we found the slope of the normal. What's next? Everything else is the same. We need the y value of that point at x equals 2. To find the y value at x equals 2, we will plug in 2 into the main function, which will still give me 9, which means that the normal has a slope of negative 1 over 4 and passes through the point 2, 9. We can now write down the equation of this line as y minus 9 equals m times x minus 2. And that is the slope of the normal equation. The slope of the normal line. So this is it. Literally, these are like a few steps of work, and the only new thing that you need to remember is this stuff. Everything else is something you've already known from previous topics. Okay? The derivative tells you the slope of the function. A tangent has the same slope as the function. A normal has the negative reciprocal as the slope of the function. And that's it. There's nothing else. Okay? These are the only new things you need to remember for IB calculus derivation questions at least. Okay? Now with this said, we can look at one tough question. One of the questions that I gave you as homework. 1 second. So it says, so we have a function and we want to find the equation of the normal to the curve of f at the point where x is 1. What does that even mean, right? Look, whenever you see normal to the curve or tangent to the curve, the first instinct needs to be where? At x equals 1. So you need to find normal at x equals 1. That's the main goal. Everything else is gibberish. Okay, that doesn't matter actually. So now what do we do? First step, always find the derivative. To find the derivative, use the power rule. Sometimes your problem will have square roots and cube roots in it. Convert them to powers. Okay? So 4x cubed will become 3 times 4x square because you multiply by the power and subtract 1. And 2x, let's figure out what this becomes. Remember, 2x means 2x to the power of 1, right? X has a power of 1 on it. So you multiply by the power, same as usual, and subtract 1 from the power. What is the new power? It's 0. And what does a power of 0 mean? 1. Anything to the power of 0 is 1, which means that 2x will just become 2, because x to the power of 0 is just 1. So we have 12x squared plus 2, and that is my derivative. If you want a shortcut, remember, whenever you see a constant, the derivative is 0. Whenever you see a times x, just a single power of x, the derivative is just a. The x goes away. Okay? Everything else is just like business as usual. Okay? Use the regular power rule in those cases. All right? So these are the two kind of, if you want to memorize them, go for it. I don't suggest that, but some people prefer it for some reason. So these, oh God. Yeah. Now that is why 2x became just 2. As I said, ax becomes just a. So, to find the normal at x equals 1, you found the derivative. Step 2, find the derivative's value at x equals 1, which will be 14. Step 3, this is now specific to normals. If it's a tangent, you will say the slope of the tangent is whatever the slope of the function was. But if it's a normal, you have to do negative reciprocals. Since we are looking at a normal, we have to do minus 1 over 14 instead. Perfect. Now, step 4, find point on curve or on function basically. We already know that x equals 1 is part of the coordinate, but that's only one thing. What is y? Right? That's what I mean. You want to find the y value too. How do we find the y value? Literally just plug in x equals 1 into the main function, which means 4x cubed plus 2x becomes 4 1 cubed plus 2 1. Which is 6, which means that y is 6. So finally, normal knows two things. The slope is minus 1 over 14, and the point of intersection is 1 and 6. Set up the equation. Y minus 6 equals slope times x minus 1. And that's it. Question is done. So 5 steps for 6 whole points. Okay? And honestly, I don't even consider these to be separate steps. You're literally finding the derivative, plugging a single value in, and then making a statement. This is one single step. This is finding slope of normal. That's it. Okay? So as you can see here, it's a similar thing. Actually, no. This is the first question we've done, so it makes sense. So let me know if you guys have any questions about this. And with this said, you should be able to try to do all of the questions at least. Attempt them. And the ones you guys have are completely blank on, let's work on those in the next class. All right. So yeah, that's about it.